Hi, I'm David Siegel. The more you study the climate system, the more complex you realize it is. I've spent a lot of time recently re-studying and understanding the greenhouse effect, and I realized that most of my previous videos weren't as accurate as I would like them to be. There's a lot more to it than I thought. In this presentation, I want to try to put the climate conversation in perspective. I've broken this lecture into 6 separate videos you should watch from beginning to end. This is technical material that forms some of the basis for my climate classes. There's much more to the classes, but this is a great start. I'm always trying to be less wrong, not more right. So if anyone sees something I should correct here, please leave comments and sources so I can learn more. These videos are meant to be watched in their numbered order. In my view, the 2 ways to think about the Earth's climate are with a radiative model or a thermal model. The radiative model looks at the energy balance between incoming shortwave radiation absorbed by the Earth and the long-wave infrared energy leaving. This is a popular but inaccurate model of the climate system. In the real world, energy coming in gets converted to heat, and that heat gets transported not just back up to space, but via 4 important gradients that we'll explore later. So let's start at the beginning. At the sun's core, 2 hydrogen atoms fuse into a helium atom, creating a huge amount of energy in the form of plasma, gamma rays, and high-energy photons. Once a photon is generated, how long do you think it takes, on average, to make its way out from the core to the surface of the sun, moving at the speed of light? Got your answer? Well, it takes on average about 150,000 years to get from the core of the sun to the surface of the sun. And then, once it's far enough away from everything blocking it, that photon escapes and begins its journey into the solar system and beyond. Now, 8 minutes later, a tiny fraction of those photons arrive on Earth. About 170 petawatts of solar energy arrives on Earth at all times. About 30% of those photons that should hit the surface are scattered away by clouds, land, and water and go back to space. What happens to the photons that are absorbed by the atmosphere and surface? We're going to look at this 2 different ways: the radiative model and the thermal model, starting with the radiative model first.